Okay. So do you want to go over the preparation part 2?
Sure. Sure, yeah. Got to review. I did it yesterday, so I'm like, okay. Got to get back into statistics mode.
All right,
Okay.
so for number 6, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? And that was the 3 ones that we looked over at the beginning. That's simple random sample is drawn from the population, x bar is normally distributed, and standard deviation is assumed to be known.
Which was interesting because it was a repeat basically of question 4, same answers.
Yeah.
I'm like, huh.
I was like, wait, there's 3 more assumptions?
Yeah, that's what I was looking at. I'm like, I don't get that. Okay. Keep me on my toes. Okay, so number 7, what is the point estimate for the population mean? And I figured it was just asking me what the mean was. So it's 541, and that's what the answer key said. So that's, I don't know, I didn't know how other than just to say it's the same mean, you know.
Yeah, there's nothing else to put.
And then on number 8, when I went through that one, I did the applet that the teacher gave us rather than the one that came with the BYU Idaho stuff. And mine was just barely slightly off, where I guess if you rounded it, I mean, it's really close. But I got, instead of 532.13, I got 531.949. So what did you get?
I got 532.13.
Did you use, which applet did you use on that one?
I didn't use an applet. I just did the equation.
Oh. Which equation did you use?
I'm
trying to think.
So
I'm
pretty sure this is the equation I used. I did so x bar minus, let me get the right number. 1.960 because it's 95.
Okay.
And then it's multiplied by the standard deviation divided by the
square root of n.
Yeah, square root of n.
And then okay, you did that equation. Okay,
and then I did the positive one too.
Yeah, and I just did the, oh wait, so okay, so yours was the x bar on that one minus that, because there were 2 equations for that one, right? You just had to switch around according to what you were looking for.
Yeah, so I just did the minus and the positive because it was looking for both. Wait, no, not 0.645. I did. Oh yeah, 0.960. Sorry.
1.960 or 1 point. You did negative, so x bar minus 1.960 times by the standard deviation divided by the square root of n. And then I'm trying to remember the rest of that equation. But yeah, I just basically went into the probability applet and I typed in the, switching over to the value, put in the 0.95% for the area, and it gave me the numbers, and I wrote those down. I'm like, oh, okay, that's really close.
Yeah.
But I guess accurate than the equation. But I mean, it was right in the same ballpark.
Yeah, I was doing one of the equations and I was like getting really close. And then I realized that I wasn't doing the 95%. I was doing like the 90 or the 99 or something. And I was like, oh, that's why. I think, I was thinking I was doing the 90% instead of the 95, which is 0.33 difference. But it really did make the 0.3 difference.
So I'm going to put their use equation.
Yeah. And then I just did the equation for the next one as well.
And that was, yeah, I'm trying to find in the pages where it was.
I can tell you.
Okay, x bar minus z.
It's like around 4.1.3. 4.1.2. Or
Number 9. Okay, yeah. I'm
Yeah,
looking
so
at
in the 4 section, section 4 for their lesson plan, it
right.
has like all of the
Yeah, it's
equations.
I found it under the step 4.5 example after 4.4 requirements. Just before it has answering the questions, it has the x bar minus z.
Multiplied.
Okay, I'm just gonna, I usually like to write those equations in just so that I remember them when I go back. How'd you do on the test?
Did pretty well. I saw that
We're recorded.
he
Comfortable with
answered your,
the
what was
test
that?
that we did? Yeah, he did answer my question. I was just asking how comfortable you felt with the test.
Oh, it wasn't bad. I'm glad it was shorter than the practice test.
Yeah. He's like, well, if you can do this, then that means. Okay, so there, I have the equation written down. That makes me feel better. Okay.
And then if you
Okay.
want to write down the confidence level things, the 90, 95, and 99.
Oh yeah, I know that has.
Those will tell you the
Yeah.
percentage that you should put in.
Yeah, I've got that one. I flipped to that one multiple times during this assignment.
Yeah.
Okay, so yes, then going to number 10, I have to find some way to actual materialize this. I just kind of looked at it going, okay, the margin of error, I looked at the answer key and I'm like, okay, that makes sense. I'm just trying to understand, do the sample, up the sample size, what the result is. And for me, it's just a matter of memorizing that.
Yeah. But it makes sense, like the smaller the sample size is, the smaller that. I always just do like, remember like, oh, if it's smaller, it's smaller. If it's bigger, it gets bigger for me.
But
Because some of them are always like,
go ahead.
I don't know.
I was just looking, but on like number 10, didn't it say, okay, maybe I wrote that one down. Okay, wrong. Grows larger, margin of error. Okay, I'm looking at the homework answer key. That's really messing me up. Wrong one. Okay, so number 10, margin of error gets smaller as the sample size grows larger, and that's smaller and larger, remembering which one goes where.
Yeah.
Yeah, I need to make sense of it better right now. It's just something I'm trying to memorize. Okay, 90% confidence interval for the original 50 students. And I think, yeah, I wrote that down. Oh, I did actually do the equations for 8 and 9. I just wrote them on the bottom. Okay. That makes so much more sense. I got that wrong. Yeah, well, the reason I got it wrong was I was doing the minus the 2 instead of the other number there.
0.96 or something.
That's why I got the 8 wrong. Okay. And the 9, I did the same thing, and that's why I was just slightly off because of the what the 95% was. Okay. So number 11, I actually have written down, and I did it the right way. I have the 1.645 timesing in there. So yes, it was 533.556 and 548.444.
Yep, that's what I got.
Gosh. Okay, well, I'm glad I write these things down so I can actually see where I screwed up.
Yeah.
Okay, number 12. And that was where we were looking for the n, so a different equation.
This one's the margin gets smaller.
Yeah, how does the margin of error? I labeled that one wrong. That was my number 13 instead of 12. Okay, number 13 is where you're looking for the number.
Yes.
And it's
with a different
equation. It wants to know how many students they need to be able to get the margin of error down to a 5. So that's when you take the n equals, in parentheses, the z times by the
standard deviation
divided by the m squared. So
yep.
that would to be 157.351936, which rounded up to 158.
And I always remember that you can't have 157.3 people because you can't have like a third of a person.
Yeah.
So you have
And
to
always rounding up. I did get that one, but okay, so I guess we're on to the quiz.
Yep.
I'm still getting it loaded up.
Alright. 14 questions.
I think I'm going to open up the applet too, just in case.
Sounds good.
I mean, I didn't use it a lot in this, but it was there. Okay. Find the margin of error. And I think he's probably going to make a spreadsheet with this one again in the lesson.
Oh, that'd be nice.
Because it takes so much time to, you know, like when, especially on the last few answers where you're only changing one thing, you have to go through all the work again for that one thing. So, okay, the margin of error means that equation of the x bar minus z, right?
Let me see. Because this one's looking for a confidence interval.
X bar z is by the and divided by n.
We don't know the x bar.
Okay, find the margin of error of a 90% confidence interval with a standard deviation of 50 and the n equals 25. So we can get the z-score with the 90% from the applet. And then we have the other numbers there. Just going, well, actually, yeah, does 90%, is that in the box or is that the one we need the applet to compute?
That's in the box.
So what was that number?
It was 1.645.
1.64 would be our z then. So, okay, but we're looking for the x bar. Okay, and we're supposed to find the margin of error. Is there no other information?
So we need to find m equals that equation.
Really?
So it'd be m equals, I don't think it's 2.
N equals the z standard deviation divided by m squared.
Which one is that one?
That's the n the equation. Where did they write that one in here? If you're looking to solve n, it's in the sample size calculations. Number 5 has the n equals, in parentheses, the z times by the standard deviation divided by m squared as the sample size formula. Is that what we're looking for?
We're looking for the margin of error for 90% confidence. So I found one that says m equals z.
Oh, so we're looking for m is what you're saying. I'm like, what? Okay.
Yeah, I think
so we're looking for So we're looking for the equation on how to find m. But that's okay.
So I think m is margin of error.
It is. Yeah.
Okay. And then so the question is asking find the margin of error for 90% confidence interval when the standard deviation is 50 and the n is 20. Oh, the n is 25. Oh, so we already have the n. Okay. I don't know what I was thinking of. So we have.
Okay, that's where you take the m is equal to the z times the, but yeah, okay.
Times the standard deviation over n.
Right. So. And we're trying to figure out what the n is, which random sample.
And the n is 25. Yeah.
Okay, so let me get the right equation here that we're doing. We are doing the x bar.
I'm doing.
Wait, no.
M. So it's in number 4, or under number 4. It's m equals whatever percentage, and then it's standard deviation over n squared.
N squared? Okay, I have, okay. Okay, I'm like, wait a minute, I'm really confused. Okay.
Sorry.
So we have the m is equal to the z, basically, right? The z square times divided by the square root of n, and that will give us m. And then once we have m, then we can do the number. Wait, no, we're not looking for that. We're looking for the m only.
We're just looking for the m.
Okay, excuse me, my mic.
You're fine.
One of those days. Okay.
That's fine.
So 0.90 is equal to, wait, no.
It's 0.645 for 90%.
Oh my gosh, okay. Yes, I really need to get my head back into this. Okay, so the 90% is 1.645 times by the standard deviation of 50 divided by the square root of 25. That should not have been that difficult to come up with. Okay. So you got 16.45?
Yeah.
Okay. Which of the following true? An interval estimator.
I think it might be number 2.
Okay. Point estimators and interval estimators. And why would you say it was 2? Just, was there something in the book that says it?
It just says I don't know. Okay, it says, if we know, the short answer that we will never know for sure if X bar is close to mean. This does not mean that we're helpless. Says the laws of probability and the normal distribution provide a way for us to create a range of plausible parameters or values for a parameter mean based on the statistic of X, and this is under point estimators.
Yeah, I'm actually
So
on that paragraph.
it might be number 3, if that.
M is a point estimator of X. Plausible
Sure.
range for.
I just need to know which one is which. Like which one relies on the other.
So they all have X and, well, the two center ones have X and mu. The other ones have the standard deviation squared. And I don't see anything about the standard deviation squared on the interval estimators.
Well, I see standard deviation, but.
Well, yeah, but
No, that's
the other option of that. Okay, it's a commonly confidence interval is a commonly used interval estimator. How to create confidence interval for the mean when that is known. And they don't have the mean anywhere with the standard deviation in any of those options. I'm thinking, yeah, it's either the second or the third one, and I've got to read through and figure out why. Okay, we have one. But it does have the sample statistic and the population parameter in the chart of having the mean.
That's originally what I was thinking, but.
X is a point estimator. M is a point estimator. Okay, the sample statistics we've discussed. The statistics above is they are just one number that is used to estimate a parameter. Parameters are populations, right? So the X is what you're using to. The X is what you're using to estimate. Let's see, because you're estimating the parameter. The point estimator is just one number that is used to estimate the parameter. So the X is what you use to estimate the mean, right?
Yeah, because if the mean is unknown.
So that would be the second one, is a point estimator of. Because it's saying what a point estimator is. Okay, which of the following statement is true? Point estimator is what one point that we use to estimate a parameter. Parameter is population. On the graph, it puts the mu as the population parameter. So I'm thinking the X is what you need to be able to estimate the mean. So I would guess 2. I don't know for certain.
It says
but that would be my guess.
The parameter is based on the statistic of X bar. So
where's that?
So it just says it right at the end of the paragraphs in 3.1. Says the laws of probability and the normal distribution provide a way for us to create a range of plausible values for a parameter, e.g. mu, based on the statistic, e.g. X bar. So based on, so it basically says the mean is based on X bar. And then backwards,
based on
X is what the mean needs. I don't know if this makes sense.
It's saying yes, the parameter they have is mu and the statistic they have is X. In that last sentence. But if we're looking for the point estimator, right? Because it's saying one is a point estimator. So we're looking for which one the point estimator is, and it says that they're just one number that is used to estimate a parameter. So a parameter is the population. So I thought the parameter would be the mu, or to estimate the mu, that would be the X. Does that make sense?
A little bit. I'll be right back. I have to plug in my charger for my
Okay.
computer. I'm sorry.
No problem.
Sorry.
No problem. I'm just browsing through papers too.
So in 3.3.3, it talks more about X bar from the mean and the mean from X bar. So I don't know if that will help us.
3.3.3.
Mm-hmm. I don't see anything.
Well, it's a quiz. If you want to put the one, I'll put the other one.
Sure.
I've from what I'm reading and trying to understand, I'm guessing it's number 2, but if you're feeling strongly it's 3, then we'll figure out which one it is.
I'm with you though. I think it might be because that's what it says in the little graph, not the graph, the chart.
Mm-hmm.
It has the X bar, then the mean.
Yeah. Well, and I was just looking at like the definition of the point estimator is saying that they're using a point on a number line that's used to estimate a parameter, and they did say that the parameter was the mu because it's a population. So I think you're using X to be a point estimator to find mu.
Mm-hmm.
So that would be my guess.
I think that's it.
Oh, we get the GMAT scores one now. Yay.
I,
I wish it was printed out because I like to always circle when they give me the information, but.
Yeah. Make sure you know which one. I lost my pencil.
Yeah, we're going to use this information for the next 6 questions. Okay. Point estimate. So it's asking us what the point estimate, what is the point estimate for the true GMAT score?
Okay.
It wouldn't be, would it be 526? I don't know. No, that's a, yeah.
Well, the last point estimate was the mean.
That's true.
Wasn't it?
Well, let me look back on that one.
Oh, yeah. What is a point estimate? And it says it is the mean. So I'm comfortable with putting the mean as.
So we're not given the mean though, right?
I guess not.
Last question that we asked, we said that X was used to find the mu, and that we were saying is the point estimator, if we answered the question before, would say that X, right?
What was that?
We said X is a point estimator of mu. So if we're asking down here on the next question, they're giving us X bar. So if we're saying that that's really true, that X bar is a point estimator of mu, then the point estimate, I'm wondering If that would be
We'll
the
be about fine.
526. I don't know. Let me try and find the point estimator thing.
So we can find like the confidence interval. Yeah, we can find the interval between, or what's it called? Like we can find the values right next to the
Oh, here.
point
I do have a sample of it in the homework that was done. It was giving us all the information. It says, what is the point estimate for the population mean? And that's why I put in the population mean. This one's saying, what is the estimate, or what is the point estimate for the true GMAT score?
Mm-hmm.
So, yeah, when they did the point estimate before, it was the population mean, which is why I did the sample mean. But this one, we're not dealing with so much a sample mean as we are a GMAT score, which is saying what is the point estimate for the true GMAT score.
Mm-hmm.
Is there another one here with the GMAT scores? I know we've done those before.
Mm-hmm.
Yeah, because the other ones they actually say what is the point estimate for the population mean. So that's why I put in the mean, but this one doesn't say anything about the mean. It's saying what is the point estimate for the true GMAT score.
Maybe the true GMAT score is the mean. I don't know. What is a point?
I'm looking at all the other times it's asked me to look for the point estimate.
So the point estimate is like the number that we subtracted and added for the formulas.
Mm-hmm.
And then,
So did we put that in place of x when we did that? Because 0.16.
yeah. I think so.
Yeah, we used it as x bar basically when they gave us the mean earlier. So the x bar it's giving us. So rather than saying the mean, that's what we're looking for is the x bar, because the last question we answered was the one that said we're saying the x bar is what we use to compute it. So
526?
I would say 526.
Okay. And
Then we need to do the margin of error, which is that's where we take the z-score times by the standard deviation divided by the square root of n, right?
Mm-hmm. And it's 95%, so it's 1.960.
Standard deviation is 113. And the n is 64. So did you get 27.685?
Yep.
Are we supposed to have the 3 decimals there?
Probably, let me see.
You hold on for just one moment and I will be right back.
No problem.
Thanks. Sorry about that.
No, you're fine.
Okay. So we got 27.685.
Yeah, and I think we have to do all of the decimals for 3.
What is the lower limit of this control?
I think this means those two equations where it's x bar minus z square multiplied by standard deviation over square root of n, and then the upper is the plus instead of the minus.
Oh, because those are the next two questions, so the upper and the minus and the lower.
That's
Okay.
what I just kind of assume.
Okay, so x bar is 526 minus z 1.960 times by 113 over square root of 64 plus z. Try. I just need to write these numbers down instead of just doing them on a calculator. Like, okay, that's what it was before, but I guess it doesn't take that long.
I always write them down to make sure I'm getting it right.
498.315 for the lower one.
Mm-hmm. Yep.
The other one was 553.685.
Yep. That's what I got.
Okay, what would happen to the width of the confidence interval if Gina increased the sample size? I think we just had that answer.
Mm-hmm.
Let me look back to it. So we're looking at the, sorry, back on, with the width of confidence. If Gina increased the sample size. So as the sample size increases, the interval width decreases. So if she's going to increase the sample size, she's going to decrease the interval width. You agree?
Let me see.
It's number 16 on the homework. Oh, sorry.
Is it number 12?
I had number 16 on the homework, but we didn't.
Oh,
you didn't do the homework.
I didn't do the homework.
Sorry.
No, you're fine. So on the preparation answer key. No, that's a different one.
Yeah, preparation answer key. I mean, the preparation
margin of error.
gets,
so not the smaller as the confidence grows gets smaller.
Right. If you look at your homework number 16, it says, what do you notice about the relationship between the sample size and the width of the confidence interval? And basically, as the sample size increases, the interval width decreases.
Okay.
And I know, just because I was looking at that, I'm like, I know I've been asked that.
Mm-hmm. And there's something similar, but not quite the same on the preparation.
Yeah. Well, and that's the thing, is they'll ask you all different variations of it, and you're trying to help you understand the full picture, but sometimes I'm like,
This isn't helping.
Yeah, I need someone to explain. I'll ask my husband. He's good at explaining things.
Mine too.
So then
So
we actually
you're
have
saying
to.
decrease, correct?
Yeah, I'm saying that yes, because it says if or as the sample size increases, the interval width decreases, and that was asking us what the width would be.
Mm-hmm.
What would happen to the width of the confidence interval? And it was
Okay.
asking, yeah, it was asking the question specifically about the width of the confidence interval.
And
then it says what would happen. What would happen to the width of a confidence interval? That seems like it's the same question.
I should change it
but
to 99%.
she's changing it to 99 confidence interval. So what would happen to the width? Last time we were looking at what happened to the width. If she increased it, so she's increasing the width this time? Okay. Width
I
of
know
the,
that she's making it 99%.
so we're trying to figure out what would happen to the width of the confidence. And 99%, is that our sample? That's not our sample size.
What was that?
So now it's asking us for the confidence interval and the width of the confidence interval.
So there's a question in the lesson plan. It says, what would happen to the confidence interval if the sample size n was increased? Is that what it's asking?
But we're not doing, well, I don't know. That's what I'm trying to figure out because it's saying what we want to know what's happening to the width of the confidence interval if she's changing the 99% confidence interval. So I don't see n in there. She's changing the confidence interval.
There's this one.
Trying to
What would
figure out
happen to the what would happen to the confidence interval if the confidence level were increased from 95 to 99? It says increasing the confidence level will lead to larger values of z. If z is increased, then the margin of error would increase. This would lead to a wider confidence interval.
So that's going to lead to the wider one, which means increase. And where was that found?
This was in one of the little green boxes in 4.2.
4.2.
It's number 7 in 4.2. It's the second question in the little green box.
Okay, let me just get to that. I want to mark that one. 4.2, number 7. Okay. I highlighted it.
You knew.
Those are the things I'm trying to understand instead of just find it in the book. But
yeah.
Okay. Next question.
Light bulb. They're trying to assess the average life expectancy of their light bulbs. Their standard deviation is 400 hours. They want 95% confidence interval, and they have a margin error of 50 hours.
So they're looking for the sample size, which is the n formula, right?
Yeah, so we're trying to find n.
So you have the n is equal to the, I put the z-score. Yeah, because the 95% confidence level, 160. I mean, 196.
Which one? 95 is 1.960.
Yeah, so.
Where's your, oh, okay. Actually, I have it written up there.
And always remember to square it. One time I didn't square it because I just got lost the square. So did you get 245.8624?
245.8624, yeah. So we would do
And then you round up to
246.
246.
Yep. All right. Got another thing.
The mean of salary of actuaries, standard deviation. Okay, so now you're doing the null hypothesis or alternate hypothesis. Okay.
So we're throwing it back.
What is the lower limit of this confidence level? And that's where we did the
minus.
X bar minus Z times the
standard deviation
next
over
time.
N.
Yeah, next time I'm actually just going to keep a line paper and write it down as I go instead of all these scrap pages. Okay. So our X bar in this one is that going to be the mean of actuaries as 100,000? No.
So I think we have to. You collect simple random sample of 36 women's salaries and
Oh yeah.
So we do.
The X bar is.
Do we do 111,000 minus 100,000 over?
So X.
Or just
X is
plug
111. I think we just plug the X in as 111,000 because it's giving that to us.
Oh, because the mean is 100.
Yeah.
Didn't we have like one where we did X bar minus mean all over? I forgot which formula that was for, but we'll just do
Let's
this.
see.
This is what we did.
We're looking for the lower limit, so yeah, that's where we would do the minus the X bar, which is 111,7,000. Subtract the Z score, which is going to be
95, so 1.960.
1.960 times by standard deviation 36,730, and that's going to be divided by the square root of n, which is 36. Did you get $99,001?
Mm-hmm.
And then 53 forever?
Yeah.
It says round to the nearest whole number, so it'd be 99002.
Yeah. That's what I got. And
$2.
Upper.
And we got something, but we subtract. So did you get 1,998?
Yep.
Or 667, which would be 12,000 or 122,999.
Would we do that?
Sorry, it rounds to the nearest whole number, right?
Yeah.
So we have 122.
We would just do 98 instead of 99.
I don't know. And all the stuff that we had before, they had us round up to the whole number. Let me look and see which ones. I know we did lots of times, but I don't want to confuse myself. I'll go to that section on that.
Because it's not a 0.5 being rounded up, it's a 0.4 being rounded up. So I can see.
I guess I was just looking. I was just looking at rolling how they rounded up the whole number, but that was probably only when they dealt with people.
Yeah. This is money.
Yeah. Okay. Now I'm trying to see where I put my answer. Ah, there it is. No, my calculator. Okay. So 1, 2, 2, 9, 9, 8. Or were we keeping the 0.47?
Is it 6 or 7?
Wouldn't we round that up because you have 0.4667? So if you're trying to round up to the 0.46, it's the next one is 6, so you'd round it to 0.47.
So I see like as if it's
okay.
a 0.466, we round up to 47, but that's still not 50.
Right, round up to the
Does that
nearest
make sense?
whole number. I was rounding up to the 2 cents or to the tenths
Yeah.
and hundredths. Okay, whole number. Yes, that's right. I told you I'm having a really difficult day today.
It's okay. We are almost done. So.
Yeah, thank heavens for today. Okay. 3 requirements that need to be checked when computing the confidence interval for a mean. They are that the simple random sample was drawn from the population. It's all of them, isn't it? Wait.
Yeah.
Normally distributed, and we have to know those. So I think it's all.
Yeah, so it's X bar is normally distributed, and standard deviation is assumed to be known. A simple random sample was drawn from the population.
Yeah, so it's all 3 of those. So they gave them all to us, and
all of the above.
Okay.
And we'll submit it.
See how we did.
We did great. We got him.
Okay, good.